Canaveral, the world's most talked about piece of real estate, was the sand and palmetto stage for a spectacular show during 1962. Man in Orbit, the thrilling flights of astronaut Glenn, Carpenter, Schirra, the launching of Telstar, and live transatlantic television. Muscle added to the nation's missile might as Titan and Minuteman joined the combat-ready forces of Strategic Air Command. A 182 million mile voyage of Mariner to Venus, the last test flight of Atlas. This is Cape Canaveral, 1962. Wednesday, December 5th, 1962. This is Atlas Day at the Cape. An all-Air Force crew, veteran airmen who began with the prop-driven aircraft and progressed through jets to the rocket age, and the young airmen of the new age prepare Atlas number 544 for launching. This is the last of the research and development flights for this stainless steel giant, the 105th launch in the series, which began at Cape Canaveral on June 11, 1957. That first flight lasted but 58 seconds, ending in a mass of flame that was visible for miles. As short as the flight was, the Atlas team, a close-knit group of Air Force and aerospace industry engineers, collected facts or data, the real payoff in research and development flights. More tests, more facts, and the 82-foot-tall, 130-ton missile gained in reliability. Its 3 rocket motors developing thrust to hurl a dummy warhead more than 9,000 miles down the Atlantic missile range. And now, on this day, December the 5th, 1962, the last research and development flight. All systems were go. The Air Force crew moved smoothly through the countdown without a hitch.
Propulsion, go. Autopilot and hydraulics, go. GE Airborne, go. RF system, go. Acoustica, go. Landline, go. Telemetry, go. Nose cones, go. Fuel and launch control, go. Pneumatics, go. Water system, go.
Ignition. Liftoff. Atlas 544 is on its way. The accurate eyes of the camera record the even flame pattern, and the vernier engines burning on the sides of the Atlas indicate response to the guidance signals, already aiming the payload toward the proper point in space. The mighty Atlas, combat ready, a rugged, reliable deterrent weapon operational with the Strategic Air Command. And now the Atlas programs. That is, it turns into its trajectory. Telemetry signals give the earthbound crew a real-time reading on flight progress. High above the Earth, cameras installed to give the engineers a good look at first stage burnout and booster separation are triggered into action. These cameras drop off 600 miles downrange to be recovered by Air Force pararescue men. The instrument-laden nose cone will be picked up 5,000 miles downrange by an Atlantic Missile Range ocean vessel. The mission is complete, and back at Cape Canaveral, the book is closed on an era while attention turns to new challenges. And the challenges are unlimited. In mid-October, an Air Force crew counted down a Minuteman, America's first instant ICBM. This 3-stage solid fuel missile had established a record of reliability. The Minuteman roared to life in the 80-foot deep silo. The range safety panel flashed the red danger signals. When the missile veered from course, the range safety officer sent the signal to destroy it. It was a spectacular display of pyrotechnics. Flaming debris started fires that caused some damage on the Cape. This failure produced knowledge needed to further refine the missile subsystems, and Minuteman was soon back in the go column. Developed in minimum time under the concurrency concept, the Minuteman became combat ready with the Strategic Air Command in December. With a range of more than 6,000 miles, the 56-foot-tall, inertially guided missile can be fired in less than a minute's notice from its underground hardened site. The Air Force will place several hundred Minutemen in dispersed sites around the country. For a relatively low investment, the Minuteman weapons system will pay great dividends in strengthening the nation's deterrent force. Before one of the newly commissioned atomic-powered submarines is deployed on patrol in various parts of the world, it undergoes a shakedown cruise, including the launching of a production model Polaris down the Atlantic missile range. The sub submerges in the Atlantic Ocean off the shores of Cape Canaveral, and the crew prepares to launch a missile downrange. At count 0, the Polaris shoots from its tube underwater to the surface. Its solid fuel igniting when clear of the water, and another atomic submarine is ready to move on station. Testing of the second-generation Polaris was completed, and it joined the fleet as an operational missile in 1962. And the more powerful A-3 Polaris, designed for a 2,500-mile range, scored a partial success on its first launch in September. The U.S. Army-developed Pershing continued its highly successful test series at the Air Force Missile Test Center. Designed for mobility and fast reaction to fit the Army's modern arsenal, the solid-fuel two-stage missile can be fired at selected ranges up to 250 miles. Launching the Pershing from its mobile carrier, the Army gained valuable operational data by conducting some tests under simulated combat conditions. The Atlantic Missile Range, extending some 10,000 miles from Cape Canaveral, Florida, to the Indian Ocean, has been called the world's largest laboratory. A measured, exacting course where the ideas of the scientists and researchers and the hardware of the engineers and the builders are put to the test. The Air Force Skybolt was one such piece of hardware and was first launched in April. Slung under the wing of a B-52 bomber, the Skybolt is dropped from the mother ship, falls free, and at a safe distance, ignites, and is on its way. After a short distance, the missile pitches upward and enters a ballistic trajectory. Another test series begins in the world's largest laboratory, Cape Canaveral. If the 1962 chapter of aerospace history at Cape Canaveral can be given a title, a strong vote could be cast for Time of the Titan. In mid-January, the last Titan I was launched shortly after sundown. The 110-ton liquid-fuel two-stage ICBM wrapped up a highly successful test series in spectacular fashion. But even before the last Titan I was launched, the first of the Titan IIs, a larger, more powerful rocket, engineered to the current state-of-the-art, had arrived at Cape Canaveral. Its delivery by an Air Force transport marked the beginning of painstaking preparations for launch. Even the cargo compartment of the large plane receives special engineering to fit the new Titan. Clearance, for loading and offloading at some spots is less than an inch. And the new missile is handled gingerly as it is moved to the modified launch pad. The Titan II is erected on its launch stand a stage at a time, mating the second stage to the booster. The erector is also a service tower. The first stage is placed on the steel-framed erector, brought slowly to the upright launch position. A detailed checkout of every component is required before the launch count begins. The Air Force industry team operates with emphasis on quality control. This missile is powered by chemical fuels, capable of being stored for fast reaction time to meet the military requirements and exact launch schedules for rendezvous missions in space. The Titan II is earmarked to boost the two-man Gemini space capsule into orbit and to form the core for the next generation super booster, the Titan III. Observers at the Cape watching the first launch on March 16th of Titan II saw a new ignition pattern, reddish-orange smoke, and two jet-like streams of flame as the Titan developed its 500,000 pounds of thrust. The first flight met all test objectives. First stage separation 90 miles out happened as scheduled. All systems functioned as planned as the instrumented payload sped downrange. In September, President Kennedy paid his second visit of the year to Cape Canaveral. On an earlier trip, he had decorated astronaut John Glenn. The purpose of this tour was to take a closer look at Cape facilities, one of 4 stops on a 2-day flying trip. Greeted at the Cape's landing strip by Major General Leighton I. Davis, Atlantic Missile Range Commander, and Dr. Kurt Debus, the NASA Launch Operations Center Director, the President and his party rapidly moved out to the first stop, Pad 14, and a short briefing by astronaut Walter Schirra and the Atlas crew who would soon stage America's 3rd orbital flight. At Pad 16, the President had a good look at the Titan II. The party, which included Vice President Lyndon B. Johnson, Secretary of Defense Robert McNamara, Secretary of the Air Force Eugene Zuckert, the NASA Administrator James Webb, and other high-ranking government officials, received a briefing on Atlantic Missile Range operations and the Titan program. A model of the Titan III was shown publicly for the first time, and the presidential party was briefed on the Titan III's future role as a booster. Next, through the Saturn complex, where the President received a detailed account of the giant booster program. Finally, to Hangar S, a meeting with astronaut Gordon Cooper, and a word of thanks to the assembled military and civilian workers. Houston, Texas, the new home of NASA's Manned Spaceflight Center, was the next scheduled stop on the presidential tour. And then a farewell salute from General Davis and Dr. Debus as the presidential plane Air Force One departs Cape Canaveral. General Davis, Atlantic Missile Range Commander, has commented that 1962 was a time of transition at the Cape, a transition from missile development to space operations and space probes. There was a significant increase in the number of launches to place satellites into orbit and to send instrument packages to the far reaches of space. A practical application of space is its use in weather forecasting. 3 TIRUS satellites were placed into orbit during the year. Boosted by a Thor Delta, TIRUS transmits pictures to Earth on demand. These pictures have contributed much to man's ability to understand his age-old nemesis, weather. During the summer evenings of 1960, a favorite American pastime was watching Echo, a balloon in orbit. Echo 1 proved the value of passive communication satellites. And in 1962, the National Aeronautics and Space Administration achieved a significant breakthrough in Project Big Shot, a 13-story high polyethylene balloon, paper thin, was folded carefully in the nose cone of a Thor Delta. Observers at the Cape watched the package hurtle over 900 miles into space, still sparkling at apogee like a new star. Cameras and television transmitters aboard the booster recorded the successful deployment of the balloon, following it down to the Earth's atmosphere where it burned. Satisfied with test results, NASA engineers looked to an early orbital flight for the big balloon. Near the tip of the Cape, at the south end of ICBM row, stands Pad 36. Its bright orange gantry higher and shaped differently than the adjacent Atlas towers. It's the launch complex for NASA's Centaur, a 107-foot-tall hybrid rocket, boosted by an Atlas and further powered by a second-stage liquid hydrogen engine. After a year of preparation, the Centaur was launched at 49 minutes past 3 the afternoon of May 9th. From these pictures, the experts learned the reason for the failure. A metal surface between the stages buckled under aerodynamic pressure. An engineer will look at failures differently than the casual observer. A test flight that produces knowledge is not a failure. New dimensions were added to man's understanding of space with the successful voyage of Mariner 2. The mission, to put a satellite within looking distance of the planet Venus, some 30 million miles away. A navigation problem which would defy solution without today's electronic computers. For this interception, the Mariner could not take the straight line distance between 2 points, rather a long curving orbit covering 182 million miles and taking 109 days. The Air Force Atlas, teamed with the Agena space vehicle, carried the Mariner to the departure point in deep space. The trip began at 2:35 in the morning on August 28th. The Agena was placed in Earth orbit by the Atlas, and at the proper time, the Agena kicked Mariner into its long arching trail. Its course was corrected shortly thereafter, and on the afternoon of December 14th, the electronic eyes and ears of Mariner scanned Venus from a distance of 21,000 miles, flashing the facts to Earth by means of a high-pitched radio signal. The NASA-developed Mariner 2 was an unqualified success in the conquest of space and scientific exploration. The scientific community has learned to look to space for some of the answers to problems about the Earth. An example is Anna, a 350-pound, 36-inch sphere, circling the Earth every 107 minutes, 600 miles up, flashing a light at designated times. Scientists of the world use the man-made star to improve mapping capabilities and to validate geodetic measurements. Anna, whose name came from the initials of Air Force, Navy, NASA, and Army, all participating agencies in the project, was launched into its near-perfect orbit by an Air Force Thor Able at 8 minutes past 3 on the morning of October the 31st. A joint United Kingdom-United States satellite launched by a Thor Delta rocket on April 26, 1962 from Cape Canaveral is symbolic of international cooperation in the peaceful exploration and utilization of space. Telstar brought the world into the American living room. A Thor Delta rocket placed this communications satellite into orbit. Developed by private industry, this 34.5-inch sphere made possible instant mass communication. Placed into an elliptical orbit ranging from 600 to 3,500 miles high, Telstar made possible transatlantic live television transmission for the first time. In December, a second experimental communications satellite, the Relay, was launched from Cape Canaveral. However, power problems threatened to render the new communicator silent. Man in Space, the biggest news story of the year from Cape Canaveral. Marine Colonel John Glenn in February. Navy Commander Scott Carpenter in May. And Navy Commander Walter Schirra in a perfect 6-orbit mission in October. A pattern was established. The pre-dawn ride from Hangar S to Pad 14 in the transfer van. The walk to the elevator. The squeeze into the capsule. The countdown building suspense as the TV cameras in the blockhouse give a close-up view of the frost-covered Atlas rocket and capsule. 26 ships and 150 aircraft move into position around the globe to support this flight. Liftoff. The rocket and capsule rise slowly from the pad. For Commander Schirra, the 6-orbit flight covering 160,000 miles went exactly as planned, with Sigma 7 being dropped squarely on target near Midway Island in the Pacific for pickup by the carrier Kearsarge. One man, alone in space, now in safe descent, a perfect ending, a result of a tremendous team effort. The National Aeronautics and Space Administration, charged with the awesome responsibility of placing an American on the moon, heads this team. Support comes from many areas, from the scientists and researchers around the nation, from the aerospace industry, which produces the hardware, from the global resources of the Department of Defense, 18,000 people manning ships, aircraft, and communication stations around the world. This is the Mercury team, well-trained, professional, and motivated. The precise operations in the 6-orbit flight demonstrates the proficiency of the team. Still in his Sigma 7, Commander Schirra elected to wait for the carrier Kearsarge. Then, in Navy tradition, the astronaut asked for permission to come aboard. And Schirra emerged to a resounding welcome from all hands. At year's end, Air Force Major Gordon Cooper is in training for the next Mercury flight, a 34-hour mission scheduled for early spring. And 9 new astronauts were added to the program for coming Gemini missions. Of real significance is the expansion and building program going on at the Cape. Station number 1 on the Atlantic Missile Range grew by 80,000 acres with the NASA acquisition of land from the Merritt Island launch area. Multi-million-dollar contracts were committed on preliminary preparation of this land, preparing it for the bigger launch pads and a heavy launch area needed in the mid-60s. A pad for Titan III, Saturn C3, and C5. And other heavy launch vehicles are needed. Work on Complex 37, a double pad launch area for Saturn, was nearing completion at year's end. The third success in as many tries was credited to the Saturn on November the 16th. The huge booster, a cluster of 8 liquid-fueled engines, was assembled at NASA's Marshall Space Flight Center at Huntsville, Alabama. Much too large for air transport, the booster makes a huck fin trip on a special barge, following the river route to the Gulf and up the inland waterways to the Cape. Saturn is handled by the experienced missile men at Complex 34. Erected with its dummy upper stage in the 308-foot-high gantry. Thought to be the most powerful rocket in the world, this Saturn will be followed by later models developing several million pounds of thrust. The mighty Saturn is almost ready for launch. Preparations continue. And Dr. Werner von Braun, a pioneer in liquid fuel rockets, and NASA director of the Saturn program monitors the count. The Saturn ignites in a thunderous roar. Its agonizingly slow liftoff takes more than 10 seconds to climb the first 300 feet above the pad. And as it accelerates, the rockets develop over 1 million pounds of thrust, and the 162-foot-high, 550-ton monster trails a wake of flame over 300 feet long. Approximately 5 minutes after launch, the dummy upper stage has exploded, dumping 23,000 gallons of water on the fringe of space in a scientific experiment. This Saturn test, SA-3, met all test objectives. A look into the future of Cape Canaveral. This modified Titan II, with its two 120-inch solid fuel boosters, is the launch vehicle for the experimental X-20 Dyna-Soar, a maneuverable spacecraft. This artist's concept will show the sequence of events after the launch of the three-section Titan. The vehicle will drop the two solid fuel boosters as they burn out. Then staging of the Titan II core as the Dyna-Soar approaches insertion into orbit. Circling the globe at speeds greater than 17,000 miles an hour, the pilot will be able to select his own place of landing, and guiding the craft will begin its re-entry. It was during the Air Force Association's 16th annual convention in September that the 6 Dyna-Soar pilots, 5 U.S. Air Force and 1 NASA civilian, were introduced. This brought to 12 the number of Air Force pilots engaged in manned orbital programs. An artist's concept of the X-20 Dyna-Soar, a look to the future. But artists' concepts do not fly, nor do they produce facts and scientific knowledge which constitute the prime resource in the space age. The men of Cape Canaveral must be concerned with the future because of the rapid move into new ideas and new concepts. But the day-to-day work at the Cape deals only in reality, a job of piecing together the results of the entire effort of the aerospace program. Assessing the activity during 1962 can lead to but one conclusion. Substantial gains were chalked up toward the nation's goals in military preparedness and space exploration. It was a year of big news stories, nearly 200 launches, a trio of courageous astronauts boosting national prestige in flights which were open for the world to see. Telstar, a move toward instant global communication. Ending of Atlas development. Beginning for the powerful Titan II. A rendezvous in deep space between Mariner and Venus. The addition of Minuteman to Strategic Air Command's deterrent force. Cape Canaveral, 1962. Threshold for America's first big steps into space looks to the year ahead, to the challenge of this new era.